going to start in the packet on page 29. So this would be support for 1324, this part of it, okay? It's really 324 because it's just lines. I mean, it's stuff that you should feel hopefully comfortable with. If not, you will be. All right, so everybody online, you guys can see my screen?
Yeah.
Okay, good. All right, so linear equations, lines, you know, it's basically something that just y equals something times x plus something else. So there's three forms. The two you're going to be most interested in are the first one and the third one. The first one is called slope-intercept because m is called the slope. All right, and b is called the y-intercept. All right, so when you have the slope of the y-intercept, you just plug them in. Be careful with the graph. The y-intercept is where it crosses the x-axis. It's right here. This is b. All right, b is not where it crosses the x-axis. It's where it crosses the y-axis. All right, that's a common mistake. So that's your y-intercept. Your slope is a measure of steepness. This line I drew has a negative slope. Because from left to right, it's falling, it's going downhill. All right. So a line with a positive slope is going up. As x goes up, y goes up. All right. Some lines will be flat. That's a horizontal line. That has zero slope. The slope equals 0. And a vertical line is like an infinitely steep line. So we say the slope is infinite, or we say the slope is undefined. Okay? So those are the type of lines you're going to run into. All right? But I would say now, horizontal line is like y equals 2, just like that, and vertical is like this. All right. Okay? All right, so the steeper the line, the higher the slope. Slope of 45 degrees is the slope of 1. So x, you know, when you talk about x, they call that the independent variable. It's the input. You put x in, you get y out, right? Y is called the dependent because the value of y depends on x. Okay? Yeah. So more forms. Slope point. Slope form is going to be useful when you know a point and you know the slope. All right? Because let's say I want to find the equation of the line. I'm just going to write here. Let's say I knew it passed through the point 2, 3. And let's say the slope is 5. You get the equation of the line, you just plug in the slope and plug in the point. So like this is x1, y1, just label those. And I'm just going to plug them right in here. So I would get y minus 3, y1, the slope is m is 5, times x minus 2. That would be your x. And that's all I have to do. All right, so when you have a point slope, very useful. And I can solve for y if I wanted to. I have to multiply the 5 through and solve for y. That gives me the equation. Now, standard form. Ax plus by equals c doesn't give you a lot of information. It doesn't tell you the slope. It doesn't tell you a lot. But the reason but when they ask for that, that's what they're looking for, right? So you have to make it look like that. It's not very useful. All right. So when we talk about slope, it's the change in the delta means change in. You guys ever seen a little delta report? All right, so this means change in. It's the change in y over the change in x. All right, so it's a measure of the steepness of the line. Another word they'll use for slope with lines is rate of change. You see that? What's the rate of change of this line? Is the slope. Okay, rate of change is the same as the slope of the line. So if you're given 2 points, I'm just going to label them x1, y1, and x2, y2. If you know 2 points, you can find the slope from the points. It's the difference of the y's, so it's y2 minus y1 over the difference in the x's, x2 minus x1. So if you had 2 points, that's how you can find the slope. All right? It's coming back to you guys. Slope is referred to as rate of change. We talked about that. In graph, we talk about it as rise over run. It's how much you go up and how much you go over. You go from point to point. Right? So we're going to work with some linear equations. All right. We good so far? Yeah. Okay. So here's the deal. They're asking you, is this point on this line? That's really what they're asking you. If it's on the line, if you plug in, so this is x and this is y, you're going to plug those in for x and y. And if they equal 1, then it's on the line. If it's not, it's not. All right. So I'm just going to plug it in for x and y. So I do 3 times x is 3 minus 5 times y is 2. And the question I'm asking, does that equal 1? I multiply it out. This is 9. 5 times 2 is 10. So I get negative 1. All right, so negative 1 doesn't equal 1, right? So that tells me that point is not on the line. If I got something like 1 equals 1, then I'd be happy and I'd be that one's on the line. Right? Is that right? All right. So let's try this one. So this is x and y. It's negative 2, 4 on the graph of the lines equation is y equals 2x minus 8. All right, I'll plug it in. So y is 4, and x is negative 2. 4, we get negative 4 minus 8. All right, well, that's certainly not going to work, right? It's like negative 12. So again, both these are not on the line, okay? Or to be on the line, I would have to get something like 4 equals 4. Good? All right, so to find the slope from a graph, you need 2 points, all right? The first couple, they've marked them. You want to find a point that's kind of in the crosshairs of the graph, all right? So they've marked a couple. And so what I have to do is figure out how much I have to go up and how much I have to go over to figure out the slope. I don't have to do, any points. I can just figure out that over. So if I count, I go from 1, I got to go up 1, 2, 3. I'm going up 3. And I'm going over 1, 2, 3, 4, 5. I'm going over 5. Right? So my rise is 3 and my run is 5. That's so my slope equals rise over run. So the rise is 3 and the run is 5. That's all I got to do. Okay. And it should be positive because this graph is rising left to right. I'm expecting that slope to be positive. It is. Okay. Everybody good?
Yes, ma'am.
All right. So this next one, I'm just going to count. I'm going up 1, 2, 3, 4. I'm going up 4 and over. Okay, and I'm going over, let's see, 1, 2, 3, 4, 5, 6. I went over 6, so I'm up 4 and over 6, right? So slope is rise over run. So in this case, it's rise over run, which is 4 over 6. I got to reduce that. 2 goes into both of them, so that's 2/3. Okay? All right? So in the next example, you'll see that the graph is falling left to right, so it has a negative slope. So what happens if I do rise over run? The rise is going to be negative now. But let me find 2 good points. So I didn't mark 2 good points, so I got to find 2 nice points. So let's see if I can find a couple. There's a nice one. There's a nice one. Okay, so I'm going to do rise over run. So to go from one to the other, I'm going down 2, and the rise will be negative 2, and I'm falling, and over 1. Right? So my slope will be negative 2 over 1. Rise over run. Now I don't need the negative 1, it's just negative 2, right? It's the same thing as negative 2. X gives my slope. You guys get it online? Yeah. All right, so this last one, pick two good points. Let's see, here's a nice one. Here's a nice one. Here we go. All right, so from point to point, I'm going down 1 and over 1, 2, 3. All right, so my rise is -1, my run is 3. And there's my slope. Okay. You notice the bigger the number, like the -2 is much steeper than -1/3, right? So the bigger the number, the steeper the line. Okay. Now, one of the things you guys are going to want to do is from a point, if you know the slope, you can find the second point. Why would you want to do that? Well, in video 2.1, I showed you how to do linear regression on a calculator. If you know 2 points on a line, the calculator can find the equation of the line. So if you watch video 2.1 online, you'll see how to do that. So all you need is 2 points. All right, so we get 2 points for the check. Get the equation. All right, so we can use the slope to get the second point. So let's take a look at this example. So let's say I know I have the point 3, 2 it passes through, and I know that the slope is 3/5. Right? So what you can do is you can plot the point, so x is 3, y is 2. And then we're going to use the slope to find the next point, right? So the next point, so the rise would be 3. Remember, this is rise over run. So the rise is 3 and the run is 5. So from that point, I'm going to go up 3 over 5. So if I go up 3 and over 5, I land right here, which I can read that point, x is 8 and y is 5. So I'm right at the point 5. Okay. So what that does for me is once I have 2 points, I can plug in the calculator and give me the equation line. So I don't have to plot it all out. Okay. All right. You good?
Yes, ma'am.
All right, so let's try another couple examples to get the points, all right? All right, so I'm going to find another point. So move from the given point using the slope of 2/3. Remember, it's rise over run, so you're going to go up 2 over 3. Right? So from this point, I go up 2, 1, 2 over 1, 2, 3. So there's a new point, right? My other point is 6, 6. Now, it's not the only point on the line. I could go up 2 and over 3 more, but I'm off the graph. I could also go backwards, like down 2 and over 3. The other wrong line. Okay. All right, so all I needed was another point. All right, so this next line, the slope is -4/5, so that means I'm going down 4 and over 5. All right, now here's the problem. If I start at the point, I go down 1, 2, 3, 4, over 1, 2, 3, 4, 5. I'm off the graph, right? That's a bit of a problem. So I'm going to go backwards. I'm going to go up 4 and 5 to the left. All right, so move up 1, 2, 3, 4, and 5 to the left. 1, 2, 3, 4, 5. So there's my next point. So I get 0, 6. And you can verify it works because I should be able to go down 4 over 5 and right where I started, right? So like if I go down 4 over 5, I'm where I started. Okay. Once I have 2 points, you're going to see in video 2.1 how you can just plug them into the calculator and get the equation of that line. That's what you're only able to do. Okay. All right, are you good with that? Okay, now, what do I do if it's a point like 350, 200? How excited are you about graphing that? I'm using a slope of -4 over 15. Would you be excited about graphing that? No, you don't have to, okay? If you understand it's rise over run, that means, so if the slope is -4 over 15, think of it this way. This is rise over run. So what that means is rise is a change in y. Run is a change of x. So the change in y is going to be down 4, and the change in x is going to be up 15, right? So watch what I can do. Here's my point. And so I'm going to add the rise, that's the change in y, so I'm going to subtract 4 from y. And the run is over 15, so I'm going to add 15 to x. And when I do that, I arrive at the next point, and now I don't have to graph it, right? So 350 plus 15 is 365, and 20 minus 4 is 16. So there's my new point without me actually having to graph it, okay? You guys get that? Right, and what that's going to do is let me plug that in the calculator, and I get the equation line. All right, you good? Okay, so we'll do another example. So the slope is rise over run. I'll just do change in y over change in x. The change in y is 2, and the change in x is 35. So all I'm going to do is take the point, which is xy. Delta y is 2, so I'm going to add 2 to y. And delta x is 35, so I'm going to add 35 to x, right? Now give me a new point. Okay. So I'm going to arrive at 65, 64 over 2. That would be a new point. So let's try the next one. Now, the slope of 40 is not a fraction, right? But you can write 40 as 40 over 1. That's what you want to do. All right, so the change in y over the change in x. Just put a 1 on the bottom and nothing on the bottom. All right, so the change in y is 40. And the change in x is 1. All right, so we take our point. I'm going to add 40 to y and 1 to x. So I get 31, 64, 40. All right, so that's going to be the 2 points that I need to plug into the calculator, all right, to get the equation of line. All right, we're not going to talk about that today because that's on video 2.1. That's for you guys to watch this week. All right, so if you don't know how to do the equation of the line using 2 points from your calculator, you want to watch that. Okay, I'll show you how to do it. All right, everybody good with this? Okay, thanks. Okay, Kobe, I got you. I'll fix it. All right, you good? Yeah? Okay. All right, so that's a support material. Now we're going to switch up and we're going to talk about multiplying polynomials. That's the math 224 step. All right. I think it's like page 100. All right, everybody good? I can change the page. 200. Let's try 101. All right, page 101. We're going to talk about multiplying polynomials. There's a couple ways to do it. Just to kind of refresh your memory. Some people like to just do it by hand, like what she's got here. Some people do a box, and I support them to do a box. I don't care how you multiply it as long as you can. I'll show you both. All right, so the first way, when you're multiplying a polynomial times a polynomial, basically you have to multiply every term by every term. And the most organized way to do that, I put the smaller one up front, the larger one in the back. So I take the first term, which is 3g, and I would multiply that by every term of the polynomial, so all the blue guys. All right, so go down here, this is where she's worked out. You have 3g times 2g squared. Right, that'll be the first one, and 3g times 4g, and 3g times negative 4. So all the blue ones are there. So you see I did the first term times every term of the second. Okay? Then when you're done with that, you're going to take the second term, which is the guys in the red. So I can do the negative now. The one thing with this, it's a negative 3. It's not 3, it's a negative 3. Take the sign with it. All right, so you do negative 3 times each one of these guys. So it's negative 3 times 2g squared. Here, negative 3 times 4g right here, and negative 3 times negative 4. Okay? So you're doing every term by every term. Okay? Now I just got to simplify. So 3g times 2g squared, you multiply the number, you get 6 and g cubed. And this guy would be 12g squared. This guy would be negative 12g. And red guys, negative 6g squared, negative 12g. Plus 12, so negative something negative, okay? So you multiply them all together. Then you collect like terms. I kind of like to line them up vertically, she did not, so I'm going to take the cube term, all right? Then I combine the squares terms. So 12g squared minus 6g squared is 6g squared, all right? And then I got negative 12g and negative 12g, that's negative 24g, so that goes here. And you have your plus 12, right? So you multiply, you combine that term, and you're done. Okay, everybody happy? All right, so we're going to do some multiplication. And you got to remember your exponent rules for this a little bit, all right? So first thing I'm going to do is, once one term, I just distribute to both of them. We're going to do 2x times x, which is what?
2x squared.
2x squared. And then I'm going to turn my plus 2x times 3 would be
6x.
This is where we got to know our, oh, I want to talk to you a little bit about signs, because this is where I see the mistake as an algebra teacher, a former algebra teacher, all right? So what if I did this? All right, what would I do first on that?
Negative 3 times x plus 2.
Good, right, you don't do 2 minus 3, right? Because order of operations, you have to multiply before you add, right? And then negative 3, it's really, really important that negative be carried to both of those. I've taught long enough, a lot of people forget to carry the negative down, all right? So what you do is you do 2 and you have minus 3x, and you have a minus 6, right? So negative 3 changes the sign of both of them, all right? And then you collect them. 2 minus 6 would be negative 4.
Negative 4.
All right, so make sure when you have a negative out front of something you're multiplying, you take that negative to everything you're multiplying. All right, I would see that mistake probably 20 times a week to know. Okay. All right, so we're gonna multiply this next one, just distribute. So 2x squared times x cubed would be 2 what?
2x to the 6th power.
Okay, so what do we do with exponents when we multiply?
Oh, add them.
Add them, right? So we
Okay, so to the 5th power.
fifth, right? So that's when the exponent rules come back around, right? All right, so now we're going to multiply 2 times 3 is 6, and x squared times x is x cubed, right? Okay? All right? All right, I'm going to show you guys the box. If you're a fan of the box, that's fine. I'm just going to refresh your memory. I'm not a fan of the box, but if you like it, you can use it. All right, it's a little longer. So what you do to set up a box, you make a box. There's 2 terms to this guy, 2 things, and there's 3 things in this guy. So you make a 2 by 3 box. Okay, so make a box. But it doesn't matter. It's just got to be 2 by 3. And what I do is the two termers, I put those outside here. So minus 3x and minus 4, I put those on the outside. And the three termer will be x squared, x, and negative 3. And then I multiply every row by every column. So x squared times negative 3x is negative 3x cubed. And x times negative 3x is negative 3x squared. And negative 3 times negative 3x would be positive 9x. So I just multiply rows and columns. All right, now I'm going to have the second row. So negative 4 times x squared is negative 4x squared. Negative 4 times x is negative 4x. And negative 4 times negative 3 is positive 12. All right. Now, this works well for combining terms because now I got all the terms laid out and I combine my terms. So it's negative 3x cubed. You see, I have two square terms. So I can do 3x squared and negative 4x squared. So negative 3, negative 4. So I add this together to get negative 7x squared.
Yes.
So negative 7x squared. Up to this guy 3. So here in this guy, I get 9 and negative 4x. That would be 5x. Right? You have 12 left over. Right? So now I multiply them. All right. So if you like the box, you're used to the box, don't do the box.
Isn't it supposed to be negative 3x cubed?
Did I mess up? Oh, yes, it should be. It should be a cube. That doesn't look good. Here. Yeah, absolutely. All right, you guys good with that? Online, you good? Any questions? Okay. All right, so again, I do every term by every term. I'll just multiply these to show me, like, I'm going to multiply x by x, so I get x
X
squared,
squared.
x by negative y,
Negative x squared.
I've done x, now I'm going to go y times x. I'm going to write that as xy. And y times negative y is minus y squared. All right? If I add these up, the xy's cancel. And I get x squared minus y squared. Okay? This is called a difference of perfect squares. Next Thursday, we're going to go the other way. We're going to factor back into what it was. We have like x minus y, x plus y. It was xy term to always going to cancel. All right, can I flip the page down? Can I move down? You guys good? Yeah? No. Hold on. Let me see. Okay. It's good to have at least a few people in here so I can see what you're doing. All right. All right, now another method. All right. We have two terms inside an expression that's called a binomial. Bi means two by. When you multiply a binomial times a binomial, remember FOIL? So you use FOIL, right? First, outsides, insides, last. So that's what FOIL stands for. Okay. So basically, if I'm multiplying this, the first would be the first two. So that would be my first. So 5x times 2x is 10x squared. The outsides would be the guys on the far outside. So 5x times 7 would be 35x, right? The insides would be the 2 on the inside. So that would be negative 6x. And the last would be the 2 at the end, negative 21, right? So feel free to use FOIL, binomial times binomial. First, outside, inside, last. Once you multiply the two terms in the middle, then it would be like terms. You combine them, 35 minus 6 would be 29, right? So she moves it in. Okay? Y'all remember FOIL? Okay. All right. So we're going to do a couple of these. I'll do the first one. So if I multiply the first, x times x is x squared. The outside would be 5 times x would be positive 5x. The inside, 2x. Last would be
Negative 10.
And I combine the like terms. So these guys come together. I have x squared plus 5 minus 2 is 3x. minus 10, right? Good? Okay. And
Can
then
we
I want
also,
you to do B on your own. And we'll come back and see. I really about a minute or two. Go ahead and work B on your own. So do this one on your own. And we'll come back to your answer. Okay, somebody's brave on something what you got. Not
6x,
my person. Tell me what you got.
6x squared minus 13x minus 28?
Agreed.
Okay, good job. Right, you need to go on that and feel pretty good about it. Okay? Sounds good. Okay. All right, so a couple more. Let me pull this up. All right, so let's do this one first. Would be 12x squared. Outside would be times 4 is negative 32x. Inside 3 times 5, negative 15x. And last, negative 5 times negative 8 is positive 4, right? Negative times negative is positive. Combine the like terms. Negative 32 and 15. Negative 47. You got it.
Do we have to use the FOIL, or can we do how we were doing it earlier where we like do,
We can do the box. What we do last one in the box?
or not the box, but like if you go, can you do like negative 5 times 3x and then negative 5? Or like, yeah, that'd be the same. Never mind.
Yeah, it's all the same, right?
Yeah, I realized that after I said it.
Here, as long as you do it, right?
Yes, ma'am.
Okay. All right, last one. What she was asking me, I could just do the first, this guy times that, right? And then this guy times that, right? That does the same thing as FOIL, right? So I'll do FOIL, I guess. First would be 9x
squared,
outside, negative 21x,
negative 21x,
inside, 21x,
21x,
last, negative 7 times 7.
49.
49, there you go. Yay, all right. So if I add those together, those cancel. 9x squared minus 49. So what I want you to notice is when you have a plus and a minus, the same things, those insides and outsides, yeah, inside, no. What is it? Yeah, the insides and the outsides always cancel. Right? Something's going to cancel that because it creates a difference of squares. And Thursday, we're going to factor. We're going to go the other way. So we're going to go from this to that. Okay? That's what we're going to do first. Okay? Now, in 2.1, I show you how to do linear regression. That's what we need 2 points for. That's why we did lines there. calculators, right? In 4.1, I show you how to factor with my method, which is called backwards Australian or various method. Okay? I call it field common factor. If you have knowledge, he's not like the way I factor. So Thursday, I'm going to talk to you about how to make it not look like you're using my method. Okay? You're going to do it in your head. Okay? But you're kind of erasing on this step. Okay? All right, if he shows, if you have to show work at all, I don't know. You haven't taken the test yet, right? So I don't know how it's going to work. And it's all being online, right? That's what it is. Yes, I think you can't really make you show a lot of work, so it probably won't matter. But we'll talk about Thursday. It's not a big deal. I just erase all the steps. Okay, but I do it. I don't do it the way it's written in the notes because I'm my lazy. Okay. So. What do I want to tell you guys? So I think that's it. Okay. Yeah, I'm done for today. So we have left really. If you guys have any questions before your test, if you want anything you want me to talk about, I'd be glad to do that because I have some extra time. You guys online.
Could you go over 3 Venn diagrams, like the triple Venn diagrams?
Sure. Do you have a problem that you're looking at, or?
Yeah, no, I can give you an example right now.
Yeah, share your screen with me. You already can see your screen.
Okay.
If you're not done, you don't want to see it, you can go, but I'll help you then.
Yeah.
You have to share your screen.
Yeah, I just tried to. Is it working right now?
Let's see. Oh, I gotta stop sharing. Okay, I'm gonna stop sharing. Now you should be able to share your screen.
All right. Let's see. 1 second, please. It still says host disabled participant screen sharing.
Hold on, let me allow it. Right now.
Here we go. So this one, number 4.
Okay. Oh, this one. Okay. All right. What I like to do is start in the middle. So I start at the bottom and work my way backwards. There's a group of 100 students. You guys can see it, right? That's no. Oh, let's see. How do I share the screen? I'm gonna watch out. Let me pull this over here. Oh, try this. I gotta share it with these other guys. So I thought I could just pull it over. I know what I can do. Or Zoom. Let's just screen share what I'm gonna do. I'll do it over here. Sorry, I gotta find the right one. I should be able to just pull this. I'm going to request. Hold on a second. I'm trying to figure out how to do it. There. No. Is that it? No. Okay, I've got it on that screen, so I've got to be able to share this screen. Let's chat. How can I just pull it over? What if I exit full screen and then I pull it over? Okay. All right. I'm just trying to figure out how to share with these guys. Where's your screen share go? There it is. All right, I'll tell you what. One of three of you want to come up and look at the screen so I can see this. I'll write the problem on the board. Let's do that. Okay. So you have 100 students survey, so that's your total, right? All right, and you have 29 students that read Sports Illustrated. I'm just going to write SI for Sports Illustrated. 36 students read ESPN, the magazine. 70 students read the internet. All right. 13 students read Sports Illustrated and ESPN. Read ESPN and the internet. 19 read Sports Illustrated on the internet. And 9 read all 3. You guys online, if I write on the board, can you see the board over here, or is it too light?
It's too bright, to be honest.
Right, all right, I'm gonna kind of do both then, all right? I'm gonna get it out of here. All right. So for you guys in class, we've got 3 magazines. Sports Illustrated, ESPN, and Internet. All right, for Internet. All right, so you guys online, let me draw those out for you. So there should be the you got rid of it. Okay, well, we'll just do it this way. Back here.
Oh, sorry. Do you still want me to screen share it? I just assumed since you wrote it down.
I'll have to write it all out. Are you able to screen share? All right. Can you guys online see it? Let's go here. Annotate. All right, so we got basically 3 things. We got here. Oh, it's not a, I'm just going to do it in my mouse, which I hate. I'm going to do it. I can do it. All right, draw. So these circles aren't going to look pretty if I do it in mouse. All right, Sports Illustrated. Say yes. Illustrated. What do we got? ESPN. These are really fun circles. You use them with mouse. ESPN, and then the last one's the internet. My suggestion to you is to work this problem backwards. Start with all 3. So it says that 9 read all 3. That's the overlap of all 3 circles. So I'm going to put in 9 right here in the middle. All right, so for you guys in class, my 9 goes right here. Those are the ones that read all 3. Okay? You guys good with that? All right, take care of that. 19 read Sports Illustrated and the internet. So Sports Illustrated and the internet is the overlap of these 2 circles. So I know that this needs to add to 19. So I already had 9 in that little wedge. So this needs to be a 10. All right, so for you guys online. All right, Sports Illustrated and the internet is this little wedge right here. See where I'm circling? And that needs to add to 19. So that tells me that the number right here, oh, didn't work. I was hoping I could do that. The number right here needs to be 10. See why I did that? Because now I got 19 that we both. 30. Read ESPN and the internet. So ESPN, the internet, let's see, that's this overlap right here. Needs to add to 30. So I do 30 minus 9 is 21. All right. So I go over here. All right. So Sports Illustrated, no, ESPN, the internet would be this little overlap right here. See where I'm circling? So that needs to add to 30. So this needs to be a 21. So I get 30 out of there. Okay. Is that all right? All right. Then I took care of that. 13 reads Sports Illustrated and ESPN. So 13 is this overlap, that's this overlap, needs to add to 13. So I already have 9 in there, so that means I have to put a 4 in there to get 13. Okay? So I get Sports Illustrated and ESPN. That's this wedge right here. That needs to add to 13, so this needs to be a 4. Right? All right, that takes care of that. All right, 70 total read the internet. So that means the sum of all these numbers and I need to add 70. So I'm gonna do 70 minus 10 minus 9 minus 21. I need to calculate that. So I'm gonna calculate what that number is.
30.
What is it?
30.
30. So this number needs to be 30. That means I'll add to 70. Right? So to get the internet, get the I circle to add to 70. This guy right here needs to be 30. So if you add all these numbers in I, it'll be the 70. Okay. All right, 36 for ESPN. So ESPN is this circle here. So I need to add these all together, and this guy's going to equal 36. So it's 21 minus 34. So I need 2 more to get 36. So this needs to be a 2. All right. So these guys need to add a 36. All the guys need, so this is going to be a 2. Right? And then Sports Illustrated is 29. So if I add those up, let's see, Sports Illustrated is the S circle, 19 and 4, 23. I need 29, so that's going to be a 6 right here. 19, 30, 23. I need a 6 here, right? And it's 29. I have one more number I got to take care of. 100 people were surveyed, so I need somebody to add up all the numbers in here. Tell me what they add up to. Add up all the numbers in the circle. I think I did it in my head. You check it though. What do they add up to?
88.
88? I got 82. 30, 40, 50, 60, 70, 80. I had 82. Somebody else add it.
Yeah, that's 82.
82. All right. So they add to 82, but I know there were 100 people surveyed, right? So there's some people that don't get any of them. So if I do 100 minus 82, that's how people put on the outside, right? So 100 minus 82 is 18, right? So you have 18 people on the outside. Once you fill these diagrams out, you can answer any question, right? So the question they ask is how many students read only Sports Illustrated? So only Sports Illustrated, that means no overlap. So we're talking about 6 people right here, all right? So the only ones that read Sports Illustrated were the people that are only in the S. So that would be this number right here, okay? All right, how many people don't read any of the 3 items? That's the person on the outside, which I didn't write here. We decided that was 18. Okay, so that answer to B should be 18. All right. All right. Is that it for that question?
Yeah, that's it. Thanks.
All right.
Would you,
So
does
what
anyone else have a question? Because
I'm asking you to start working backwards. It's a lot easier.
yes, ma'am, you explained it very well.
Oh, sure. Thanks. Anything else you want me to go over?
I mean, if you wouldn't mind, you could also go over 5, but if anybody else has questions, you can definitely prioritize them because my,
Go over question 5. Sure. Yeah, there you're going. Yeah. Okay. So go ahead. I'm going to clear my writing here. All right. Go ahead and let's look at 5. Okay. So another survey one, right? So again, I'm going to, I don't know what I'm going to do with this one. Let's see. I'm going to see what I can. All right. It's a harder one. All right. So we got food here, 200 college students, spaghetti, pizzas, and hamburgers. All right, so we draw in circles. Spaghetti, pizzas. Yeah, if you don't want spaghetti, I'm not spaghetti, pizza, hamburgers. So what I look for is, what are the easy things I can fill in? That's what I look for. All right. So we kind of draw you guys a Venn diagram. All right. We've got spaghetti, pizza, hamburgers. All right. Now, okay. So what I'm looking for is numbers that are easy. I'm still going to work it backwards. It's easier to work backwards. The first statement is 10, 8, none of these foods. So 10 on 8, none of them. Those are the people that go out here. So there should be a 10 on the outside. All right. So let me draw that. Okay, this took care of that one. All right, it says 28 all three. So that's the overlap in the middle. So the 20 should go right here. All right, so you guys put 20 here. That's 28 all three. Okay, that's done. All right, 88 pizza and hamburgers, but not spaghetti. Okay, that's still easy to deal with, all right? Pizza and hamburgers is this little wedge right here, right? And I know that that needs to add to 80. So this needs to be a 60, right? Complete that wedge. All right, so for you guys, pizza and hamburgers is this wedge right here. So this needs to be a 60 before we get 80 out.
You put it in spaghetti
Did I
and
put it in the wrong
hamburgers.
one?
Yeah.
I guess I did. That's why I did put it on one. You should write on one. All right. There we go, like that. Okay. All right. So that takes care of that guy. 115. 8 pizza, but not spaghetti. We're going to come back to that one. All right. Just come back to it. 48 hamburgers. But not pizza. Okay. I'm gonna see if I can get something. Okay. 145 8 pizza. All right. So this is where I get to get a little creative. All right. 115 8 pizza, but not spaghetti. So pizza and not spaghetti. Oh, that's not bad. Here, pizza, but not spaghetti. I'm going to draw that. So pizza and non-spaghetti. Let me draw that. I'm going to outline that in different colors so you can see it. Somewhat draw it on pen. All right. Let me just do it. All right. So pizza and not spaghetti. All of this, is that okay that I'm drawing in yellow? I'll get you guys in there. So that has to be 115. So I'm going to do 115 minus 8. Get that. So I think I get 107 here. All right. So for you guys in class, if I eat pizza but I don't eat spaghetti, I have to leave this side out, right? Oh, that was 60.
Yeah.
I added room. What did I do? Oh, that's a 60. It looks like an 8, but it's a 60. Sorry, guys. Let me clear this out. Let me clean it out. This is 60. So I'm going to do 115 minus 60. So what's 115 minus 60?
55.
55. All right, so that's what needs to go in there. Eraser goes. So this should be 55. Just something like that, right? All right, so this should be 55. All right, so what I did was, is this wedge where it has to add to, what did I say? 115. So if I do 115 minus 60, that gives me 55 for this.
Mm-hmm.
All right, so that takes care of that one. Hamburgers, but not pizza. Okay, I can do that now. So hamburgers, but not pizza would be excluding this, right? Oh, that's not going to, I need this, right? So we're going to hold on to that one. 58 spaghetti. I did. 145 8 pizza. Let's go to that one, right? Because we can pull that one in. So 145 8 pizza. So I need piece numbers to add to 145, right? So I'm going to do 145. Let's see, we're at 80 and 55 is 135. Is that right? So check me. Is that right?
Yes.
So I need to add 145, so this is going to be 10, right?
Mm-hmm.
All right, so if I fill in the pieces to add to 145, see, I'm just missing one word. So if I add these together, this is 60, 80, and 55 is 135. So there's 145, so this is 10. All right, so that was pizza. All right, now hamburgers, but not pizza. Okay, so now I've got a problem, right? I've got something. All right, so let's talk about it. I'm going to label these. All right, I'm going to label these X, Y, and Z, the ones I don't know. Okay. Now, 58 spaghetti. So spaghetti would be X plus Y plus 30. That would be all the spaghettis, and I know that that equals 50. All right, I'm going to label this for you guys. I have some overlap, so what I'm going to do is start labeling stuff. All right, so on this diagram, I don't know these three things. I call it X, Y, and Z, right? Okay. It told me that 58 spaghetti, so that means all of this has to add to 50, right? So I know that X plus Y plus 20 and 10, that's 30. Equals 50, right? So X plus Y has to equal 20. Hold on to that thought. So X plus Y is 20. Now that would be spaghetti. So I'm going to type it up here. X plus Y equals 20. That's what that equation gives me. Now, the other thing the last thing I need to get, well, I'm going to do the 200 in a minute, but we're going to do 48 hamburgers, but not pizza. That's the one I haven't dealt with yet. Okay, so hamburgers and not pizza would be, would be Z plus not pizza. I have to leave this off, right? So it'd be Y plus Z. All right. So Y plus Z has to equal 40. All right, so I'm going to draw here. Hamburgers and not pizza would be all of this, right? This right here. Y plus Z has to equal 40. Okay? So I'm going to write that equation down. Over here. Okay, last thing, it's not enough information yet. Okay, it really isn't. So what you're going to do is you know that the total is 200, right? So I have another equation from that. So if I add up all these numbers, 90 to 55 is 145. I add them up, right? Let's see, 60, 80, 90, 55, 145, right? So 145 plus X plus Y plus Z plus 10 is 155, right? It has to add to 200, right? So X plus Y plus Z plus, what did I add them up to? 155? Has to equal 200, right? Now I have the ability to solve it. I may not like it, but I have the ability to solve it. So if I do 200 minus 155, it's 45. All right? All right. Let me go write this down for these guys. So what I did, if I add these all up, and there were 10 on the outside, if I add these all up, 60, 80, 90, 100, 155, so X plus Y plus Z. I'll just write it somewhere. If I add up all the numbers, I have to add the 200, because 200 people took the survey. All right, so there it is. If I move the 155 over, I get X plus Y plus Z equals, what was that, 45?
Yes.
Okay. So now there's a really creative way to do this. It's not that bad. You get that out of it. All right, so you see that Y plus Z is 40, right? So I'm going to replace that.
It's 20, not 40.
Yeah, so it's 40.
Oh.
No, Y plus Z is 40. It doesn't really matter how you do it, but you see that Y plus Z is 40. So I could replace this right here in that equation with 40. And look at x, right? So x plus 40 plus 155 equals 200. So that's like 195, right? So x is 75. All right. So I know that x is 5. And now it's just an open door. If x is 5, go up to this equation, right? I get x plus y is 20. So if this is 5, y is going to be 15, right? So y is 15. That means z. Y plus z is 40. So 15 plus z is 40. So if I subtract 40 minus 15, I get 25. All right. All right. So you guys online, what I did, I think this will be right. I took y plus z, I knew that was 40. So I replaced this with 40 right here. So what I get is x plus 40 is 45. And x plus 40 equals 45. So pretty much that tells me that x equals 5. All right, and once I have that, I know that x plus y is 20, and if x is 5, y has to be 15. And let's see, I need z. Well, if I know that y is 15, 15 plus 1 is 40. That's going to yield me that z is 25. So we're up there. All right.
So basically, you just started from the middle, you pieced it out, and then till you found the variables that you couldn't find, and then you made it to an equation, equaled it to the universal, and then just mapped it out. Okay, for
That's
sure.
how I did it, right? And then once you have those numbers, you can answer all the
Mhm.
questions, right? So,
Yeah, no, it's definitely a little intimidating, but it's not as intimidating as it looks.
okay, yeah. So, like I said, with these Venn diagrams, what I would do is start with the thing that's really the easy numbers, fill those in, and then if you have these variables at the end, you know, you may have to help it, but I get this, it wasn't bad. Okay? All right, is that good?
Yes, ma'am. Thank you so much. That helped me a lot. Thank you.
Okay, sure. Okay, I think we're done.
Yes, ma'am. Have a good day. Have a good day.
I'll see you guys Thursday, okay? Good luck in class.
Bye. Thank you.